morning to all of you. Hope you all are good. You all are safe wherever you are. And what else can we say that because this was the biggest destruction ever caused by any cyclone, especially in our Kolkata. So we all should be. I think that we all are safe wherever we are. And next, we are going to continue the chapter of force and pressure, which we were discussing. And we are going to start a new topic that is about the atmospheric pressure. Okay. We are going to start a new topic that is atmospheric pressure. Okay. So, as you all know that I discussed a little bit about the pressure which is exerted by the gases in the last video. I discussed about what is the atmospheric pressure, not in details but in short in the last video. So I expect that you people remember the points which we discussed in our last class. And so let's move on and let's discuss that what is atmospheric pressure. The thing we discussed in the last class, the same thing we are going to discuss today also. That is what is atmospheric pressure. What is atmospheric pressure? You all know that is we know that our atmosphere, this is all made up of gases, and we know that the gases exert pressure. So if the gas exerts pressure, this means what? That the atmosphere, which is made up of gases, it will also exert some pressure on us, and the pressure which is exerted by the atmosphere, that is only is atmospheric pressure. Understood? This is what is atmospheric pressure. Okay. So you should write this in one word actually. In one sentence, you should write one sentence that the we know that the layer of the air above the earth, that is called the atmosphere, and the pressure, the pressure which is exerted due to the weight of the air which is present in the atmosphere is called atmospheric pressure. You should write the definition of the atmospheric pressure. Maybe it will be asked in your exam, maybe it may be asked, don't know, who knows it. So write it that the pressure exerted due to the weight of the air present in the atmosphere above us is called the atmospheric pressure. It's called the atmospheric pressure. Okay. Chalo, take it. So now we will be doing the first of all that we know that what is the unit of pressure and all. We have discussed all this in your last classes. One thing you should know about the atmospheric pressure. Very important thing, that 2 points. The magnitude, that is the magnitude means the value of the atmospheric pressure, that at which point of the earth the atmospheric pressure will be maximum, at which point it will be moderate, at which point it will be minimum. These things you should know. So just make a note of it. Just write 1-2 points about it, because there's nothing to understand. So write 2-3 points about that. The first point, write the first point, that is on the surface of the earth the atmospheric pressure is maximum at the sea level. On the surface of the earth, the atmospheric pressure is maximum at the sea level. Okay, write the next point. Write the next point that as we go up in the atmosphere, from the surface of earth, the atmospheric pressure goes on decreasing. The atmospheric pressure goes on decreasing on higher altitudes. This means that on higher altitudes, minimum air pressure. What is the reason behind this? The reason is the pressure increases with the increase in depth. The reason behind this is the pressure increases due to the increase in depth. In case of sea level, depth is greater, that is why the pressure is greater. In case of higher altitudes, the depth is less, that is why the pressure is also less. Okay, this is a very important point which you should know. Okay. As an example, write one point as an example, that the atmospheric pressure on the top of a high mountain, will be much less than at its base. Okay. One more important point, write it. You know that the unit of pressure is Pascal. Write down the unit of atmospheric pressure. The unit of atmospheric pressure means, generally atmospheric pressure, since it's also a pressure, it should be measured in pascals, but the atmospheric pressure is measured in millimeter of mercury. Okay, it is measured in the unit of millimeters of mercury. Write it down that the atmospheric pressure, write down the point that the atmospheric pressure is usually measured in the unit of millimeters of mercury. Write it like this: millimeters of mercury. In short, we will write millimeter Hg, millimeter mercury. This is the short form of millimeters of mercury. Okay, so this is the unit of. We know that the SI unit of pressure is what? The SI unit of pressure is Pascal. It's okay, but atmospheric pressure is measured in this unit. So you should know this. Maybe it will be asked in your exam that what is the unit of atmospheric pressure. So you will think that yes, atmospheric pressure is a kind of pressure only. So the unit of pressure is Pascal. So you will write it Pascal. Or you will write bar, because bar is the CGS unit. But no, atmospheric pressure's unit is mmHg, means millimeters of mercury. Okay, I have said you the full form and the short form both. You know both the forms, so it will be easy for you to find out the answer. Okay, now we will be discussing one experiment. Okay, this is the experiment which we will be discussing to show the existence of the atmospheric pressure, means to show that yes, the atmospheric pressure is there, and yes, the atmosphere exerts some pressure on our body. This is the experiment which is being done to prove this same point, है ना? Okay. देखो, what we will have to do? We will have to take a soft, thick piece of card. Soft means actually not soft. Actually, it should be thick and smooth. The card should be smooth and thick. What is the meaning of smooth? Means what? Smooth means एकदम smooth होना चाहिए. It should be like this, no roughness, है ना? No roughness. It should be smooth, full smooth. Okay, and it should be thick. अच्छा. This is the card, smooth and thick card. We will have to take a smooth and thick card. Number 2, we will have to take a glass tumbler, है ना? And in the glass tumbler, we will have to take water. The water is taken in the glass tumbler. Next, what we have to do is we will have to take the paper and we will invert the glass tumbler. We will invert the glass tumbler. Glass tumbler is inverted, and at this side here, like this, the paper is pressed at the mouth of the inverted glass tumbler. Okay, the paper is pressed with such a great force that no air molecules are there at the surface of the glass tumbler. Okay, so this is a suppose inverted glass tumbler. Okay, suppose this is suppose this is an inverted glass tumbler. Okay, this is the inverted glass tumbler. You will take the paper like this and press it like this in a very great force. Okay, after that you will leave it. You will remove your hand and you can see that you will keep the glass tumbler in the inverted shape only, but then also you have put the paper you have put the paper like this, so that no air is present inside the glass. You can see that without doing anything, without pasting it, the paper is not falling down from the glass. You can see it. Okay, so what is the reason behind this? Because we know that if we will keep a glass in inverted shape and we will keep a paper, the paper should fall down. The paper will fall down because the water in the glass will apply a force on the paper and the paper will fall down. As simple as this. But we can see that the paper is not falling down. We can see. You can do this at your home also. So what is the reason? What is the reason behind this? The reason is the atmospheric pressure. The reason is the atmospheric pressure. We know that the glass is applying a force on the paper so that the paper should fall down, but we know that the atmospheric pressure is also applying the force on the paper in the upward direction, and that is why the paper is not falling. That is why the paper is not falling down. Okay, so this shows that there is an atmospheric pressure which is applying a force, which is applying the pressure in the upward direction, which is applying the pressure in the upward direction, and that is why the paper is not falling. As simple as this. Because we haven't pasted it, we haven't pasted it with the Fevicol or Fevikwik or Fevigum, anything, and then also it's not falling down. Means what? There is some force, there is some pressure which is acting against the gravity, which is acting against the force of water. Because water is applying the force, then also the paper is not falling down. So what is the reason behind this? The reason behind this is very clear, that this is the atmospheric pressure. Okay, now let's come and let's start and let's discuss some of the more examples where we will see that the atmospheric pressure is playing a great role. Okay, the second is about a simple ball. Okay, a simple ball. Actually, it's not a simple ball, but I would tell it a simple ball. Okay, later further I will tell you the name of that. Okay, that is the name of it is Magdeburg hemisphere. The name of the sphere ball is Magdeburg. Magdeburg हेमिस्फीयर है ना. Okay, what is this? देखो, hemisphere means you know, or you all know that what is hemisphere है ना. Okay, देखो. So Magdeburg hemisphere is a just hemisphere. You know that what is a hemisphere है ना. Hemisphere means what? Half circle, like this. Yes, this is a hemisphere. And this is two hemisphere cut, and a spherical ball is been cut into half. Okay, now what is being done? That these two balls, if they are half, so there is a hollow space inside the ball, and if there will be hollow space, so the air particles, the air molecules will get into the ball, then what happened? These two balls are joined, these two balls are joined. We have joined the ball like this. This is the ball which is being joined, and from here a pipe is there which is doing what? This is connected to the vacuum pump. This is connected to the vacuum pump. Okay, the air which is present inside, the air will be, okay, the air will move out from this pipe outlet and will move to the outside, and inside the sphere there will be complete vacuum, means no air is present. Okay, no air is present. Okay, inside the ball no air is present. Now what happens? Here 6 to 7 horses are there which are being tied with this sphere. Here also 6 to 7 horses are there which are being tied with the sphere. They are pulling it, and these horses are pulling it in this direction, these horses are pulling in this direction. What we can see is that the horses are pulling the spheres, okay, but then also the sphere which is being joined, this sphere is not breaking. This was two different spheres. Two spheres are just joined. Okay, they are just joined, and the air which was present inside them was removed. Now there is no air, and we can see that the two in the both the directions, opposite directions. Here are 5 to 6 horses. Here 5 to 6 horses. They are pulling the sphere, but the sphere is not getting apart. Okay, so what is the reason? What can be the reason behind this? Simple reason is there that there is a atmospheric pressure which is being applied on the sphere, which is not enabling them to break. This means the atmospheric pressure is greater, is much greater than the force which is exerted by the horses. Is it so? That is why the horses are unable to break the spheres apart into two pieces again. This means here also the atmospheric pressure is playing the role, and it is not enabling the horses. The forces of the horse is lower than the force which is being exerted by the atmospheric pressure. The atmospheric pressure is very much greater than the pressure which is being exerted by the horses. Understood? So this is a very good example to understand about the atmospheric pressure. Okay, now let's move towards the next thing. Okay, that is our body and the relation of atmospheric pressure with our body. You must have I think you know that whenever we go at higher altitudes, it is very difficult for us to breathe, because at the higher altitudes we all know that there is a less amount of oxygen present, and that is why the mountain climbers carry oxygen cylinders with them. One more thing which I think that you people have heard, that whenever we climb at the higher altitudes, we more often we have seen that the bleeding of nose, bleeding of ears, nose From the nose the blood comes out, from the ears the blood comes out. How? Why these things happen? This is the question. Hannah, this is the question, that why these things happen. Okay, देखो. Uh, Actually, one more question arises, that if the atmospheric pressure has such a great force with it that the 8 horses cannot apply that amount of force, है ना, which the atmospheric pressure is applying, so we should have also been crushed by the atmospheric pressure. If the atmospheric pressure is, if it is acting on all the objects, then obviously it is acting on us also. And if it is acting on us from the upward direction, so we should have been also crushed by the atmospheric pressure, but we are not crushed, we are all okay, we cannot feel it also. Hannah, being crushed is a different and a very, it's a very different thing. Hannah, we cannot feel it also, that if there is some force which is being applied on us, why it is such, why we are not crushed, why we cannot feel it, Hannah, where other objects are being crushed by the atmospheric pressure and we cannot feel it also. What is the reason behind this? The reason behind this is blood pressure. The reason behind this is the blood pressure. Okay, we know that in our body there is a fluid called blood. And we all know that the blood exerts some pressure in our body, and the blood is in all the cells, in all the parts of our body, and the blood is exerting some, because it's a fluid, it will exert some pressure on our body, and since it's exerting the pressure on our body, that is why we cannot feel the atmospheric pressure, because the pressure which is exerted by the blood means that blood pressure, the blood pressure is greater than the atmospheric pressure, and that is why we can never understand the effect of the atmospheric pressure. Okay, now question arises that, sir, if the blood pressure is there, okay, it's very good that blood pressure is there and we cannot understand the effect of atmospheric pressure, but when we are going towards the higher altitudes, you are saying that it starts bleeding. So why it is not bleeding when we are means at the lower altitudes, when we are at the plains, Hannah? So why it is such when we are going to the higher altitudes? If it is happening in the higher altitudes, then it should happen in the lower altitude also, Hannah. Or if it is not happening in the lower altitude, it should not happen in higher altitudes also. So what is the reason behind this? Why it is happening such? So the reason behind this is, dekho, you know that the blood pressure of our body, it is constant. It doesn't changes. It doesn't changes frequently, and it doesn't changes with height and all. But as you people know that the air pressure reduces when we are at the higher altitudes. So when we are moving towards the higher altitudes, the air pressure means the atmospheric pressure has reduced, but the blood pressure has not reduced. Because the blood pressure doesn't depend upon the altitude, it depends upon the activity. Hypertension, obesity, diabetes, exercise, highly energized workouts, and all, on all these factors actually, and on energy requirement, on all these factors the blood pressure depends. Okay, so we can see that as we are moving in the upward direction, as we are moving towards the higher altitudes, we can see that the air pressure is reducing, but the blood pressure is not reducing. So at a point, at any point, at any high altitude, at a point, what happens, that the atmospheric pressure is obviously being less than the blood pressure, and we know that the atmospheric pressure acts on both the directions, in the downward and the upward, but here it is acting in the downward direction, the atmospheric pressure, because atmosphere is above us and it will apply a pressure in the downward direction, and the blood pressure acts on the upward direction. The blood pressure acts on the upward direction. So what happens, since this pressure is less and this pressure is greater, this is the blood pressure. So what happens, if this is greater, then the blood comes out through our nose and ears, because the blood pressure, that is the pressure of the blood in the upward direction, is greater, and that is why it comes out through our nose and ears. Okay, so this is the reason why when we are at the higher altitudes, sometimes we can see that the persons are bleeding through nose and ears. So this is the reason, because the atmospheric pressure reduces at that point, and the blood pressure, since it is not changed, so the blood comes out of our nose and ears due to the lowering of the atmospheric pressure. Okay. Okay, chalo, ठीक है. So all these were the some of the examples to understand the effect of the atmospheric pressure. Okay, all these are the examples to understand the effects to understand about the atmospheric pressure. Okay, we have not come to the applications yet. Okay, these are also applications, you can say, but rather than applications, these are the good examples, these are the best examples to understand about the atmospheric pressure, and that's why I've discussed all the examples with you all people. Okay, understood. So this is what I wanted to say. In the next class we will be doing the applications of your atmospheric pressure, okay, in our everyday life. Applications means the same thing, है ना. Many of the students don't know the meaning of applications only, है ना. Applications of force, application of pressure, application of this when we study, है ना. Application of friction. Applications mean what? Applications means some case studies or some examples from our daily life. Okay, the thing which we use in our daily life, in that thing where the science is being used, that is actually application. So if you are studying the application of atmospheric pressure, means what? Application means the daily activities which we are doing. In what are those activities in which the atmospheric pressure is playing a role, major role actually. Atmospheric pressure is playing a role in all the activities, but we are talking about the major role, the best examples. We will be taking the best examples to discuss the applications. Understood? So this is all for today, and hope this is very clear and you people are reading the book thoroughly. Okay, and we will be doing the next application in the next video. Okay, till then, goodbye and have a good day ahead, and be safe, okay, wherever you people are.